Bismillahirrahmanirrahim, in the name of Allah, the most merciful and the most beneficent. This is Mohsen Ali, and along with my project partner, we worked on our FIP, which is comparative analysis of different optimization techniques for load frequency control in power system. So these are the contents of our presentation, which are motivation and problem statement, literature review, aims and objectives, methodology, results, discussions and the findings, and conclusion. And further, we did the following future directions and put the references. So the motivation for our project were the frequent blackouts in Pakistan caused by load and generation imbalance due to faults, which motivated us to choose this research area to simulate the sudden load changes and obtain a controller which gives best performance according to adverse loading conditions. So the problem statement is that electrical frequency deviation is a direct result of imbalance between electrical load and power supplied by connected generators. But sudden load changes are detrimental, which require robust controllers. That is why comparison is necessary for different optimization techniques for the LFC models. So we did the following literature review and the references, and the different authors had used different um, controllers, which is fuzzy logic PDPI controller, MPC, and adaptive fuzzy logic PA controllers, and the multi-control adaptive fractional order based PIDs. Some others had used spotted hyena based two stage controllers, nature inspired computational based control methodology, ANN based fuzzy interference techniques, and our proposal is on the PSO based multi layer perceptron ANN on single and two area power system. And we had predicted reduced frequency deviations than the ordinary PSO and genetic PIDs, which has shown the reduced settling and rise time in time response analysis. But our limitations in their work were that the steady state error persisted when the frequency deviation recovers after sudden load change. So the aims for our project were to obtain a stable and robust control system by PID tuned PSO, genetic or ANN based algorithms, and compare their performance. So the objectives for our PID for our projects were to perform the mathematical and simulation modeling of single area and multi-area power system, deduce different comparison techniques for evaluation of best algorithms for governor control and tie line exchange control in the LFC scheme. So in the methodology, we performed the calculations for the selected LFC models. We validated the calculations on the simulation models, implemented the algorithms on the MATLAB models, validated the implemented algorithms, and we did the comparison matrices with respect to time response analysis of frequency deviations for both single and multi-area power system. And we did the following calculations and chose the time constants and the base MVA for single area multi-area, which is 1000 MVA, and chose the following inertia constants and the speed regulation constants. So for the single area, this is the single line diagram, and two area, this is the single line diagram. So from area 2 to area 1, there is power flow, and in the single area, the generated power goes directly to the load. So these were the calculations that we had performed and calculated the mechanical power changes, and then the tie line power flow, and the change in the area 2 load and change in the area 1 load, and per unit changes in the load and the steady state frequency deviation. So we validated the results on the simulations of the frequency in the two area system and had confirmed the calculations of the model, and then the tie line power, and then these mechanical power calculations. So we applied the following algorithms, which is particle swamp optimization based PID, genetic algorithm based PID, and the PSO trained artificial neural network. So these were the flowcharts of the PSO genetic and the PSO trained ANN. So these were the MATLAB Simulink models on which we performed the calculations and then applied the algorithms. So through the implementation of algorithms, we choose the MATLAB Optim tool to perform the genetic algorithm, and then it allows you to choose the fitness function and the number of required variables, and this is the number of iterations, and then we see the reduction of error. So this is the applying of adaptive neural network training on single area power system model. So as you can see that here we are using the single area model to train the ANN network because it requires some base model. So as you can see, the training regression is 0.87. So which is not enough because we require 0.9 to train the adaptive neural network. So according to our proposal, after addition of PSO-PID uh, uh, based single area power system, the ANN training went from 0.87 to 0.99941. And then the following mean square error reduction was also seen from 10 to power 0 to 10 as power minus 5. So this is the ANN training GUI provided in the MATLAB tool, and the and and the single area power system model, and this is the single area power system model. Basically this is a diagram which shows the constants and then the flow of the single area LFC scheme. So we obtained the following frequency graphs, and we saw the power system frequency deviations and at different transient load changes for PSO genetic and PSO trained ANN performance in the form of in the form of time response analysis. So we obtained them for 10%, 20% to 30% for single area power system. So after these time response graphs, we summarized our results in the comparison matrix, in which we had summarized the values of peak time, delay time, and the undershoots and overshoots. And as you can see that the PSO ANN has reduced the frequency oscillations uh, very well from genetic algorithm and PSO based PIDs. We also did the following calculations in two area power system model. In the two area power system frequency deviation, and we saw the frequency deviation graphs at transient load changes for 10% load changes, 15% and 20% respectively, and then summarize their results in the comparison matrix. similar to the single area power system with respect to time response analysis. As you can see, also in this case, PSO based ANN was also able to reduce the frequency deviations. So, to conclude our work, we would say that the maintaining load generation requires robust controllers to maintain the nominal frequency and voltage values. So, PSO and genetic algorithms provided a reduction in frequency undershoots, but they were not as impactful than the PSO-NN because our proposed technique provided best results than the PSO and genetic PIDs with respect to time response analysis, as evident in the comparison metrics. For future directions, LFC schemes, new optimization techniques can be employed, such as model predictive control and adaptive fuzzy logic control for evaluating further comparison. So, uh, other comparison techniques can also be employed, and LFC plus AVR, which is automatic voltage regulation schemes, can both be used simultaneously to evaluate the same algorithms. So these are the references from which we had taken our and understood the literature. So thank you very much, and please subscribe the Electrical Engineering Sakhar IB University page and follow us on the Facebook. Thank you very much.